Students, we are going to move to example number 1. And example number 1 says that we have water which is at 20 degrees centigrade flows with an average velocity of 2 centimeter per second inside a circular pipe. Determine the flow type if the pipe diameter is 2 centimeter, 15 centimeter and 30 centimeter. So they want to know whether this flow is laminar, transition or turbulent. So first things first, we need to see what is given. So the temperature is at 20 degrees centigrade. We need to see what is the density of water from this table number A3. So density of water at 20 degrees centigrade is 998 kilogram per meter cube. Then we need to see what is the viscosity. So the viscosity, if we look here, then we can see that the viscosity, dynamic viscosity mu is 1.002 into 10 - 3 kilogram per meter second. So 1.002 into 10 - 3 kilogram per meter dot second. So part 1 says, since we know Reynolds number is equals to rho v d over mu, so density is 998 multiplied by the velocity is 2 centimeter. So we need to convert 2 centimeter into meter. That would be around divided by 100, so 0.02. So 0.02 multiplied by the diameter of the pipe, if it is 2 centimeter, this is also equals to 0.02 whole divided by 1.002 into 10 exponent minus 3. So RE for part E comes out to be 398. Now this 398 is less than 300. The range at which the flow becomes laminar. So since it is less than 2300, so we say this is laminar flow. So I will leave the second part for you guys to solve. We move to C. So RE is equals to 998 multiplied by 0.02 multiplied by 30 centimeter means 0.3 whole divided by 1.002 10 exponent minus 3. This comes out to be 5970, and this is how much? This is turbulent. So this is how we can determine the type of flow, whether it is laminar or turbulent, based on the calculation of Reynolds number. We are going to move to example number 2. Here again the water is flowing at 20 degrees centigrade in a circular pipe having a diameter of 3.5 centimeter. Determine the range for average velocity so that the flow is always in transition flow. So we need to know the range of velocity, average velocity, V average range. So the range is minimum and the V average range is maximum. Because Reynolds number RE in transition flow is between 2300 and 4000, so it means this is the minimum and this is the maximum. So we need to use these values. So RE minimum is equals to 2300, this is equals to rho V average into D over mu. Now since the density, the temperature is 20 degrees centigrade, so the density which we found out in the previous numerical is same, and same is the viscosity. So this implies that velocity average minimum comes out to be 2300 multiplied by 0.001002 whole divided by 998 multiplied by the diameter 33.5 divided by 100. This comes out to be 0.066 meter per second. Now to calculate the maximum RE max, we will use 4000. Okay, so based on this you can get the answer. V average max for 4000 RE comes out to be 0.115 meter per second. So students, we are going to do the last example for this Reynolds number, and here we can see that the air enters at 35 degrees centigrade flow inside a rectangular pipe. So we have got a rectangular pipe. It's not a pipe, I think it's a duct, and it's 2 centimeter by 5 centimeter. Determine the maximum flow velocity. So they want V average max. They want this value before the flow enters the transition region. So since we have got laminar region, transition region, and turbulent region, so before the flow enters, so this is before the flow enters transition means that it is laminar. So we are going to use the maximum value of Reynolds number for laminar, and the maximum value for Reynolds number for laminar is 2300. So the flow will remain laminar until it is 2300, and at this maximum value of Re we are going to get maximum average velocity. So let's put this in the equation. So since Reynolds number is equals to rho V average d over mu, but here you can see that this is a rectangle, and for rectangle we need to use hydraulic diameter. So I am going to add here h. This is hydraulic diameter. So hydraulic diameter dh is equals to 4 times area square. So 4 times the area divided by the perimeter. So this comes out to be 4 multiplied by 2 centimeter is 0.02, and 0.05 whole divided by 2 times 0.02 plus 2 divided by 0.05. So our hydraulic diameter comes out to be 0.029 meter. So let's put this hydraulic diameter in our Reynolds number equation. So since Reynolds number should always be 2300 to for maximum value of laminar, so 2300 is equals to V average, and this is hydraulic diameter 0.029 multiplied by whole divided by the kinematic viscosity. So for air the kinematic viscosity is 1.665 into 10 to the minus 5. So 1.655 into 10 to the minus 5. I can write this formula in terms of dynamic viscosity, and I can write this formula in terms of kinematic viscosity into H over nu. Okay, so this comes out to be average velocity maximum until which it remains laminar before the transition of the fluid is 1.313 meter per second. So this is your answer for the last numerical of this topic. Thank you for being with me.